All right, so welcome to the next portion of this course, which is combining like terms and distributive property. And you will be able to practice this in the same place that you did last time. And then I'm going to upload a worksheet. All right, so this is the worksheet you will complete with combining like terms, and you can see some of the problems here have distributive property answers on the bottom. All right, so let's go. First, let's go to the whiteboard, actually. All right, so terms. Okay, so we know what variables are. We learned that in the last video. So what is a term? If I have x plus 3x plus 3x squared, these are terms. This is a term, this is a term, this is a term. Terms consist of numbers, exponents, variables. And you can see they're separated by like addition and subtraction signs. These are considered one term. So when it comes to multiplication and division, I guess you can say they're combined. Although this here is called a coefficient. It's a number that comes before a term. So those are some key terms there. So we have terms, coefficients, we have exponents, we have variables. And so when it comes to combining like terms, you cannot add or subtract unlike terms. Unlike terms are terms that have different variables. So x and y, these are unlike terms. They have different variables. If it does not have the same exponent, it cannot be combined. So whenever you see an x by itself, this pretty much just means x to the first, although they don't write it that way because anything to the first power is itself. So they kind of just simplify it and make it short and simple. So these are like terms here. These can be combined. This is like 1 apple plus 3 apples. How many apples do you have? You have 4 apples. And then this has a different exponent, so you cannot combine it. You must leave it as is. These cannot be added. They cannot be subtracted. So let's say that this was a subtraction problem instead. They cannot be subtracted. You want to leave them as is because remember, you cannot combine unlike terms. But you can multiply them, which is what you'll do when you do distributive property. So if I have 3 times x plus 4, this means 3 times x plus 4. So to get it out of parentheses, you're going to do 3 times x times 3 times 4. 3 times x is 3x. 3 times 4 is 12. These are unlike terms. You cannot add them or subtract them. And that's the thing with math. The rules always apply. It does not change depending on what topic you're later on doing. If I'm doing a different topic, it doesn't mean, oh, there's a new set of rules now. No, the rules will remain the same all throughout math, no matter what level you get to. So distributive property, you want to be careful when doing this because you might have some integers. So let's say this is a negative c. So this is a times b times a times negative c, which is plus a negative ac, which is just ab minus ac. And that might be a little confusing. A lot of times students get the integers messed up, but the more you practice, the better you'll get. So usually I like to upload little visuals sometimes. And so I'll upload this visual for you all on the classroom board to have. Here it is. And we can look at it together. It's just showing you how to do distributive property. And you can see it helps you with all the 4 different scenarios, which is very useful. So feel free to look at that. Here it is, bigger version of it. All right, so let's practice some combining like terms and distributive property here. And then once you get good with that, you can do equivalent expressions. We will not be doing nested fractions. Let me look at these. Yeah, we're not going to be doing these. Don't worry about these. Not sure when you'll even need these in Algebra 1. It's a very random thing to put in this unit. I mean, it doesn't hurt. Feel free to learn it on your own, but we're not needing it. All right, so let's go to combine like terms here. So here I have 1, 2, 3, 4 terms. So the p's go together and the numbers go together. Careful of the integers. So you can rewrite this. This is negative 4p plus 2p. And this is negative 2 plus 3. And it doesn't matter what goes first as long as you have the correct term. So this should be negative 2p and this should be 1. So I could do 1 minus 2p, or I could do negative 2p plus 1, which is probably what they did. It doesn't matter what order you put it in as long as you have a negative 2p and a 1. This is a more simple one. These are like terms. They can be combined. This gets me negative 10p. Here, the 3x cannot be combined with anything. This is negative 6 plus negative 1, which gets you negative 7, right? We did integers. That was in the very beginning. Make sure you get your integers down. They're important. You're going to continue to see them. You don't want to mess up your problem because of it. Here we have a negative 4r and a negative 2r. That gets you negative 6r, and then the 5 stays as is. Feel free to keep practicing these. Okay, so now it's going to get a little more challenging because now we have some distributive property. It says combine like terms with negative coefficients and distribution. Whenever you see distributive property, you always want to do that first. Like, PEMDAS says, deal with parentheses first, multiplication first. So always distribute first. This gets us negative 4, right? 2 times negative 2 is negative 4. 2 times negative 4p is negative 8p. And then here, 2 times negative 2p is negative 4p. 2 times negative 1 is negative 2. And then we're going to combine like terms. So negative 4 minus 2 is negative 6. Negative 8 minus 4p is negative 12p. So this is a minus minus. It should be A for our answer. If we get it wrong, they'll show you how to do it when practicing on Khan Academy, which is useful. So always do parentheses first, right? Distribute. This gets me negative 4z minus 12. This gets me negative 20 plus 16z. And then we're combining numbers together and variables together. And we have our answer of 12z minus 32. And if you have any questions on this, feel free to reach out and ask. You can also do these with decimals and fractions. How fun. We also, for decimals, you can use a calculator. 4 times 1.75 gets me 7. So this here is 7y, and this is 4 times negative 3.5, which is negative 14, and this is plus 1.25y. These here are like terms, so I can do 7 plus 1.25, which gets me 8.25y minus 14, because those cannot be added and subtracted because they are not like terms. All right, we have some fractions. M's go together. So this is 2/5 m minus 3/5 m. Well, 2/5 minus 3/5 is negative 1/5 m. And then the negative 4/5 stays as is. Sorry, this is a negative 1/5. Like I said, I just didn't type the negative. So careful of the integers. Make sure you're putting your integers where they need to be. And so you can combine. Sometimes students have a hard time with these because whenever students see decimals and fractions, they automatically think they can't do it. They like automatically get overwhelmed and say they can't do it. It's the same thing. It's just you have decimals and fractions. So make sure you know and you're very comfortable with decimals and fractions outside of combining like terms. You want to be able to do them on their own first. So this unit has distributive property come after. It should have had it come before we were doing what we were doing, but it's okay. So here you're just distributing. Doesn't matter what order you go in. You can do 6 times negative 4n first, or 6 times 7, doesn't matter, but you get negative 24n plus 42. So we already went over distributive property. Here is where you can practice it on its own if you're having a hard time with just the distributive property. And this here is called factoring with distributive property. So usually, and this is pretty important when we get into factoring, which we will at the end of this course. Early on, usually like middle school level, they teach you what's called the GCF. So I have the number 21 and 35. What is the greatest common factor of these? And if you don't know what it is, you can do prime factorization. Does not matter what two numbers you start with. Any numbers, you can start with any numbers. 7 times 3 is 21, so I'll do that, and I'll do 7 times 5. All right, so these are factors of 21 and factors of 35. You can see they both have one number in common, a 7. That is the greatest common factor. So I take out a 7. 7 times what gets you 21e? 7 times 3e gets you 21e. 7 times what gets you 35? Well, 7 times 5. So it's pretty much like the reverse distributive property. You're like taking something apart. That's what factoring is. You're taking something apart, and then when you multiply it, you get back to where you started. So you can check your answer by doing distributive property. Let's do another. So we have 24 and 18. This is a negative 18, but let's just put 18 for now. 8 times 3 is 24. 6 times 3 is 18. You want to break these down into prime numbers. Prime numbers are numbers that can only be multiplied by 1 in itself. All right, so I broke it down, right? So 8 times 3 is 24. 4 times 2 is 8. 8's not a prime number. 4 is not a prime number, so I also get 2 times 2. So I now have 2 times 2 times 2 times 3, right? That gets me back to 24. 2 times 2 times 2 times 3. And then here we have 3 times 2 times 3, which is 2 times 3 times 3. So what do they have in common? They have a 3 and a 2 in common. And so what's 3 times 2? 6. And that's what the GCF is. The greatest common factor of 24 and 18, which is a negative 18, is 6. So you take out a 6. 6 times what gets you back to 24a? 4a. 6 times what gets you back to negative 18b? Well, negative 3b. There it is. I can check my answer by doing distributive property. So make sure you practice that. And then once you're done with that, that is when you then want to go to equivalent expressions. So equivalent means the same, right? Expressions consist of terms and variables. This here is what it is called an expression. You have expressions, right? If this said t plus r equals 5, that becomes an equation. If this said t plus r is greater than 5, that becomes an inequality, which you're going to see equations and inequalities later, but just know what an expression is. This is an expression. All right, so if I combine this, that would get me 3r plus t. So which of these are also 3r plus t? None of these. Right? Things can be written in different ways, but overall be the same. Like this here, this is 3x plus 2. So what else gets you 3x plus 2? This is 3x plus 2. When I distribute here, I get 3x plus 6, so it's not that. This is 2x plus 2 plus x, which gives me 3x plus 2. So this one also works. So these are equivalent expressions. They are the same when I combine like terms and distribute and do all of that stuff that I was doing earlier. And that's pretty much what equivalent expressions are, and that's this unit. So make sure you practice. You're combining like terms, distributive property, factoring, practicing with fractions and decimals, and combining like terms and distributive property in one problem. And then you go on to equivalent expressions. Skip nested fractions. Feel free to do them if you want. You can watch the video on Khan Academy, but it's not required. And you guys can always watch these videos on Khan Academy, but it's not required. The only thing I will use Khan Academy for this class is for you to use the practice quizzes, because it's a free platform. Why not? It shows you how to do stuff if you get it wrong, which is great. All right. I'll see you in the next video. Bye now.